Hey everyone. So we are going to take all we've learned about naming and put it into one nice, easy to read chart. All right. So when we are looking at these compounds, we first have to identify if they're ionic, covalent, or an acid. And then from there, we can start moving down our chart and figuring out how to name these guys. So let's go ahead and let's start with the compound SrCO3. We're going to look at this compound and we're going to say, is this ionic, covalent, or an acid? If anything starts with a H, it will be an acid, so we know it's not an acid. Ionic and covalent. Ionics are metals and nonmetals, while covalents are nonmetals and nonmetals. And if we look at our periodic table, a rough outline that is, we remember we got this stair step over here, and everything on the left side is a metal, and everything on the right side is a nonmetal, including our pal hydrogen. He will also be a nonmetal. So we look at this, it's made up of Sr and CO3. C and O are nonmetals, but strontium is an alkaline earth metal on this side of the table. So it looks like we are going to be dealing with an ionic compound here. So we know we're dealing with an ionic compound. We go ahead and we ask ourselves, does this contain a transition metal? Remember that looking at another rough outline of our periodic table, that this middle rectangle here are our transition metals, starting with scandium, moving all the way over to zinc and downward. So strontium, remember, is an alkaline earth metal, so it does not have a transition metal. So we will name this normally. No need for Roman numerals or prefixes or ate to ick and ite to us. Sr is simply strontium, and CO3, if there's more than two elements, right, it's a polyatomic ion. CO3 happens to be carbonate, strontium carbonate. Let's go on to another one. Let's look at FeO. So we're going to ask ourselves, is this ionic, covalent, or an acid? Definitely not an acid. It does not start with an H. We look at iron and oxygen. We're going to ask ourselves, is this a metal-nonmetal bond, or is this a non-metal-nonmetal bond? Well, you should know that iron is a metal, so we are looking at another ionic bond here. We're going to go ahead and ask ourselves, is there a transition metal in this compound? We look at iron and we know that this is my worst drawing of a periodic table yet, that it is in our transition metal center here, right in between manganese and cobalt. So yes, it is a transition metal. So we are going to have to use Roman numerals at some point. Remember, Fe is iron. Oxygen becomes oxide because we keep that prefix and add "ide" to the end. But we're going to need some Roman numerals. Remember that Roman numeral stands for the charge on the transition metal. Not how many there are, but the charge. And in order to determine that charge, we have to look at the partner. Oxygen, if you look, has a charge of 2-. So that must mean that iron, this one singular iron atom, must have a charge of 2+. Iron 2, oxide. On to our next example. So we are going to go ahead and try P3N7. P3N7. We go ahead and we look at this guy and we say, okay, it's not an acid, so it's got to be ionic or covalent, and it's got to contain non-metal or a metal-non-metal bond. I look at phosphorus, I see it's on the right side of our stair step. I look at nitrogen, I see it's on the right side of our stair step. So it's got to be a non-metal nonmetal bond. No charge is needed. We just let it know how much there is just by the prefixes. Since there are 3 phosphoruses, it'll just be triphosphorus. 7 nitrogens means we'll have hepta. Remember, nitrogen becomes nitride. Keep the prefix, add "ide" to the end. Triphosphorus, hepta nitride. Put a vowel in there to make it sound a lot smoother. Let's go to our next one. Let's say that we have a compound of HCl. Right away, we should be able to tell that this is an acid because it starts with an H. So this is definitely an acid. Does this acid have oxygen? It does not. It does not have a polyatomic ion. It just has one singular atom. So we're going to be using this method right here. Hydro blank acid, where the blank is going to come from our attached atom of chlorine, which will now become chloric. Keep the prefix, change to ic. Hydrochloric acid. Similar makeup of your stomach acid. Let's go ahead and try HNO3. Once again, you can probably see where I'm going with this. We have one that starts with a H. It is once again an acid. Does it have oxygen? Yes, it does. So it must be one of our polyatomic ions, A to ic, I to us. NO3 is nitrate. If it ends in 8, we're going to change it to ic, and then just add acid at the end. So this is nitric acid. Very strong acid. Let's go ahead and throw some random ones in there. Let's just not go in order this time. Let's go ahead and throw a random one at you. I know that some of us will want to get rid of those dots, so I might as well. Let's go ahead and look at PO. PO. I'm looking at this guy. I see phosphorus. I see oxygen. I look on my periodic table. I realize both of those are nonmetals, so I'm going to be using my prefixes. Remember that the first element, if it's by itself, we don't say monophosphorus. We just say phosphorus. Uh-oh. There we go, phosphorus. Okay? Right? You don't say monocarbon dioxide. You just say carbon dioxide. But if the second element is by itself, we do have to include the monoxide. Phosphorus monoxide, right? We don't say carbon oxide, we say carbon monoxide. So phosphorus monoxide. Let's see what you think about CO3N2, con. Okay, CO3N2. I look at this, no H. CO is cobalt. It is a metal. So it's got to be ionic. Cobalt is not just a metal, it is a transition metal as well. It's right in the middle there. So it's going to be cobalt. And N is nitrogen, right? So it'll become nitride. I'm looking at my CO3N2 here. I know that nitrogen has a 3- charge, and I know I'm going to go over here. I know nitrogen has a 3- charge, and that I have 2 of them for a total of 6-. That means all these cobalts must have a 6+ charge. Remember, our Roman numeral is just the charge on the individual cobalt atom, not the total. So I will not put 6 in here, or Vi. But I do have 3 cobalts that need to share that +6 charge. So each of those cobalts will have a +2 charge, which tells me I better have a Roman numeral of 2 in there. Last example before we go back to going from name to formula. Goodbye, cobalt. Get out of here. Let's go with right off the bat, you're saying to me, we got ourselves an acid. Starts with H. Does it have oxygen? Yes, it must include a polyatomic ion of PO3, which just happens to be phosphite. Right? Ate to ick, ite to us. So that ite is going to become not just phosphorus, but phosphorus acid. No need for a hydro, because we have an oxygen in there. Let's go ahead. Let's go backwards. We were going from formula to name. Let's go from name to formula. Let's go with dinitrogen pentafluoride. We're looking at this guy, and we should automatically know that we're dealing with a covalent bond here. We see some prefixes, so we got everything figured out. With covalent bonds, there is no need to balance charges because the prefixes tell us how many we need. We couldn't balance charges anyway because nitrogen has a 3- charge and fluorine has a -1 charge. These bonds they're sharing. That's why we use prefixes. Dinitrogen means we have 2 nitrogens. Pentafluoride means we have 5 fluorines. Let's go ahead and try another. Let's go with zinc nitrate. Zinc nitrate. I'm looking at zinc nitrate, and I see that zinc is Zn, and it is a transition metal. And nitrate, since it ends in ate or ite, is usually on my polyatomic ion sheet, but it is a -1 charge. And you might be thinking, wait, zinc is in the transition metals. Why doesn't it have a Roman numeral here? Well, if you remember, zinc always has a 2+ charge. He and his buddy silver are the only transition metals that have a fixed charge. Zinc has a +2, silver has a +1. The way I remember that is Z kind of looks like a 2. So remember, we got to balance these guys out. So we're going to need 2 nitrates. But remember, when we combine these guys, we can't just put NO32 or else it looks like we have 32 oxygens. We got to put that nitrate in parentheses. Then put the 2 on the outside. Zinc nitrate. Let's go ahead and look at sulfurous acid. Hey, see our friend acid here? We know it's got to be one of these guys that starts with an H. There's no hydro in it, so it's not just a singular atom. It's got sulfurous, so that means it's got to be some sort of polyatomic ion. Sulfurous must have came from sulfite. Sulfite is SO3 2-. Remember, our acids start with an H, so we gotta add an H here. But remember that hydrogen has a +1 charge, so we gotta make sure we have enough hydrogens to cancel out that 2- charge. So you better put a 2 down there. Now we have an acid that is neutralized and represents sulfurous acid. And let's do another real quick. Let's go with, we'll go with that. Copper 1 oxide. You're seeing this one and you're thinking right off the bat, I got a Roman numeral. It's got to be one of our transition metals. You're right. Copper and oxide is from oxygen. We know oxygen has a fixed charge of 2 minus, but the charge on copper is given by the Roman numeral. Remember, we got to equal these out, so we better have one more copper, making it Cu2O. That is copper 1 oxide. Let's do one more, and I'll send you on your merry way. Let's go with magnesium nitride. Magnesium nitride. I'm looking at this. There's no prefixes. Doesn't have H. Must be ionic. But look, there's no Roman numerals, so this one is just from our normal guy. Since it's ionic, though, we are going to have to balance some charges. Mg2 plus, nitride, right? If it was nitrate or nitrite, I know it could come from my polyatomic ions of nitrate and nitrite, but it is nitride, so it'll just be N3 minus. But we got to balance out these charges. The lowest common denominator both of these can go into is 6. So we're looking at a chemical formula here of Mg3N2. That is naming and formulas, everyone. Make sure that you are reaching out if you have questions and that you are trying out the practice so that you can better yourself with these naming and formula practices. To be a good chemist, you gotta know what you're working with. And to know what you're working with, you gotta be able to name them. So that's it for today, guys. Have a great day. Let me know if you have any questions.